Hi class, welcome to chapter 3. We just got done with chapter 2, so this is the first lesson in chapter 3. And what we're talking about in this lesson, as well as the whole chapter, is solving systems of equations. So just to give you a little bit of a definition of what that is, back in maybe 5th and 6th grade, you learned about solving equations. So solving one equation, solving an equation would be like 5x minus 15 equals 45, something like that, right? I probably shouldn't have used green because that's very hard to see. But you solved an equation, you solved for x. So now solving a system of equations, we just had this in chapter 2 where you had maybe, let's see, 3x plus 5y equals 15. And we put this on a graph where we found an infinite number of ordered pairs for x and for y. So when you solve equations, you solve for x. When you have a line like this one, you change into y equals mx plus b form or standard form, whatever the case might be, and then you graph it, and you find an infinite number of points that satisfy x and y. So now in this chapter, we're going to have this equation, but then we're also going to have an equation maybe like a negative 4x minus 13y equals 65, just for example. Now what we're going to find is we're going to find an x and y ordered pair that satisfies this equation, as well that same xy ordered pair is going to satisfy this equation. So that's what we're going to be doing in this chapter. We're going to be doing it in 3 different ways. This video lesson is going to be all about graphing it. We can graph 2 lines, and where their intersection is our solution. So this one is kind of nice because you guys already know how to graph. We did it back in chapter 2. Just graph both of these lines, find their intersection point, and that is our answer, or our solution. So for number 1, the very first equation, y equals 2x plus 1. Let's graph this line right now. Y equals 2x plus 1. So you see that the y-intercept is at a positive 1. You're going to go up 1. And then the slope is 2 over 1. So a rise of 2 and a run of 1. Right here we can draw our straight line. Class, it's very, very, very important when we're graphing these systems of equations to use a straight edge. In fact, I like to be so precise that I like to carry my slope out throughout my entire graph paper that I'm given. So I'm going to go up 2 over 1 again, and then I'm going to go down 1, down left 1, down 2, left 1, down 2, until I use up all the graph paper that I'm given. That way I can assure myself that I'm going to have a pretty stinking straight line. So I'm going to connect these dots here. And there we have our straight line. All right, so we are done graphing this one. That's great. Now we want to find an xy ordered pair that satisfies this equation as well as satisfies this one. So let's now graph this one. We can graph this one right now. It's in standard form. I think a majority of you feel most comfortable with graphing in slope-intercept form, which is y equals mx plus b. So let's do that. Let's solve this one for y to get it into y equals mx plus b form. Let's subtract an x from both sides. So 2y equals a negative x plus 12. And then we'll divide both sides by 2. So now y equals a negative 1/2 x plus 6. So now let's graph this one. This one has a y-intercept of 6. So I'm going to go up 6. 1, 2, 3, 4, 5, 6. And then my slope is down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. And now I'm going to connect these dots using my straight edge. Be sure you get out a ruler, class, or get out an edge of your planner or something like that so that you can draw these straight lines. So now the intersection point where these 2 lines cross, that one single point, is our solution. So as you can see, that point is quite clear. It is right 2, up 1, 2, 3, 4, 5. My answer is 2, 5. And what I want you to do is just at the bottom of your graph, 2, 5. You're going to write it in XY ordered pair form because that's what we found. We found an XY ordered pair. Now, class, there is absolutely no reason to get any of these wrong. And the reason for that is that it would take you probably 30 seconds to check your work and knowing that you would have the right answer. What you found is you found a point that satisfies this equation. You also found that exact same point that satisfies this equation. There's only one of them. In all the infinite number of ordered pairs that there are, there's only one of them that satisfies both of the equations, and it's 2, 5. So you can check your work just by substituting them back in. Put in 2 for the x and put in 5 for the y. So 5 equals 2 times x, which x is 2, 2 times 2 plus 1. Does this work? 5 equals 2 times 2, which is 4. 4 plus 1 is 5. Obviously, 5 equals 5. So the point 2, 5 checks out for this one. It has to check out for both of them. So let's make sure that it checks out for the other one as well. It says x plus 2y, which x is 2, plus 2 times y, which y is 5. Does that equal 12? Does 2 plus 10 equal 12? Yes, it does. 12 equals 12. That also checks out. If only one of them checks out, you've done something incorrect. If neither of them check out, you have done something incorrect. If both of them check, you know with 100% certainty that you have the right answer. Mr. Berge doesn't need to tell you whether or not you got the right answer because you should know yourself. So that's how you solve systems of equations by graphing. Graph both of the lines, find out where that intersection point is. That intersection point is your solution. You don't have to check your work. You could just circle your answer and move on to the next one, but I definitely recommend that you check your work.